Hello children, welcome back. Today's class, let us discuss the numerical part of types of vectors. Okay, here we go with the first question. If two vectors have same magnitude and direction, they are said to be. What are they? Same magnitude and same direction, they are called as your equal vectors. Both are equal, having equal magnitude and equal direction. So, they are called as your equal vectors. So, if either magnitude is different or direction is different, then they are said as unequal vectors, and if they lie on the same plane, coplanar vectors, and if they does not lie on the same plane, they are called as non-coplanar vectors. So, as they are asking us to have a vector which has same magnitude and represents the same direction, they said to be equal vector. So, first option must be true. So, moving to the next question, children. Second one, a vector of zero magnitude. Zero itself is called as zero vector, or other name is null vector, whose direction is indeterminate. So, where is the correct answer? Null vector. A vector whose magnitude is 1 is called as unit vector, and a vector whose magnitude is 0 is called as null vector. Moving to the third question, any vector of non-zero magnitude is called as proper magnitude. If any vector is having some amount of magnitude, then it is called as a proper vector. Zero magnitude means null vector. Some magnitude means proper vector. Moving to the fourth one, the direction of a null vector. So, I have given you few examples, children, for null vector. So, velocity of a body at the highest point, we can tell which direction is it moving, whether it is upwards or downwards. So, its direction is indeterminate. One more example also we have discussed is the position of an object at the horizon. At the horizon, no one knows that which direction the body must be moving on. So, these will come under the examples of null vector. So, the direction of a null vector, can you tell? We cannot say. Okay? Indeterminate. The correct answer is indeterminate. Cannot be predicted. Fifth one, the magnitude of a vector cannot be. Magnitude of a vector can be unity, can be 0, or can be positive. Okay. So, the magnitude itself is the positive value, or I cap, minus I cap, j cap, minus j cap, they all indicate the directions. Whereas magnitude of the vector is always either 0 or positive. It can also be 1. Okay. Hence, the correct option, it can never be negative. Moving with the sixth question, which of the following represents a zero vector? So, just now we have discussed a few examples, children. Position vector at the horizon, does it indicate a zero vector? Yes, of course. At the horizon, its magnitude is 0. So, this can be possible. Displacement vector of a stationary particle? Yes, stationary particle means whose magnitude is 0. Okay, stationary particle, not at all moving. Not at all moving means magnitude is 0. It is a null vector. Acceleration of a particle moving in a straight line with uniform velocity in the same direction. If velocity is uniform, formula for acceleration is change in velocity upon time. Acceleration formula is change in velocity upon time. But what they have told you that the velocity is uniform. What is uniform? The value of v is equals to u. So, no change. So, change is 0. So, 0 by anything will be 0. So, this indicates that acceleration is 0. So, what does it indicate? Acceleration vector of a particle moving in a straight line with uniform velocity in the same direction. Its magnitude is 0. Okay. Hence, this also can be considered as a zero vector. Force vector with a magnitude of 3 units. So, it was given that in the next case, force vector F bar is equals to 3 something. Magnitude is 3. So, something like 3 Newton, 3 dynes or anything. Okay. So, it has some direction. Force vector having some magnitude. It's not some magnitude. 3 is a magnitude. Some value is there which is not equals to 0. So, which of the following represents a zero vector? This can be possible. All the 3 are possible. This is a zero vector, here is a zero vector, and here is also zero. It is a multiple correct answer type question. Only fourth option is not possible. Okay. Well, moving to the next question. Which of the following does not represent a zero vector? Same like the previous case. Earlier they were asking for zero vector. Now they are asking non-zero vectors. Position vector of the origin is a zero vector. So, can't be taken into consideration. Not represent a zero vector. This represents a zero vector. So, that can't go with the displacement vector of a stationary particle. It is also a zero vector. This is a zero vector. This is also a zero vector. Just now we have discussed. And acceleration of vector of a uniform velocity. Yes, this is also itself is a zero vector. And now the last one. Force vector with some magnitude of 3 units. Yes. This can be a non-zero vector. So, the correct option, only correct option is fourth one. So, moving ahead with the next one, eighth question. Two vectors of same physical quantity, If the one vector represents mass, the other also represents mass. Vector. If one represents force, the other also must represent force. So, same physical quantity. Are unequal if they have same magnitude and same direction. They have different magnitudes and same direction. They have same magnitude but different direction. They have different magnitudes and different direction. What exactly the question was? Of same physical quantity, one can be unequal. Either the magnitude is changing or the direction is different. We can say that they both are unequal. So, same magnitude and same direction are equal vectors. Different magnitude and same unequal. Same magnitude, different direction, unequal. Different magnitude, different directions, of course, unequal. So, which among them is unequal, children? All the three, 2, 3, 4 are unequal vectors. So, here also multiple correct choice. Moving to the ninth question, displacement of a body can be. Displacement of a body can be, is it a unit vector, null vector, scalar, greater than the distance travelled by the body? Children, remember that displacement can never be greater than the value of the distance. Distance is the total path covered by a body from A to B and again from B to C. But whereas displacement is the vector that represents the initial point to the final position. So, clearly this is a distance and this is displacement. So, displacement is clearly less than distance covered by the body. Similarly, there is two positions, position 1 and position 2. Of a body moving from position A to position A directly, then here the distance covered by the body directly from here to here is equals to displacement of the body, that is initial position to the lines joining the initial position to final position. In this example, we clearly see that distance is equals to displacement, and in this example, we see that displacement is less than distance. So, displacement can be less than or equals to displacement. Displacement can be less than or equals to distance, but never greater than the distance. So, greater than the distance travelled by the body is a wrong one. Yes, of course, displacement can be unit vector. So, for example, it covers a distance of 1 meter or 1 centimeter. So, it can be taken as unit vector whose magnitude can be 1 and direction, some direction it must have. Displacement, of course, it can be a null vector. Okay, possibility is there, but it can never be a scalar. So, what is the correct option, children? Displacement of a body can be a unit vector as well as a null vector. So, some displacement is occurred means let us consider this also wrong one only. Some displacement they have to consider. Okay, so if no displacement is there, it can be considered as 0. For among the better options, we can see, let us see, consider it as the first option only, can be a unit vector. Okay.